Hey gang, today we're going to be graphing inequalities on a coordinate plane, which is similar to graphing a regular equation on a coordinate plane, but has a couple extra rules. So let's see what they are. First, you want to rewrite the equation in slope-intercept form if necessary. Second, graph the boundary line using slope-intercept form. If the inequality sign is greater than or less than or equal to, draw a solid line to indicate the boundary line contains the solution, and that's because of the equal sign. So if you have an equal sign, you're going to have a solid line. Then, if the inequality sign is just greater than or less than, draw a dashed line to indicate that the boundary line does not contain solutions. And third, shade the correct half plane, which gives the solution set. Above the line for greater than, below the line for less than. And you'll see what I mean as we get working. So let's take a look at some examples. Here's our first one. And this one's simple because it's already in slope-intercept form. So we start down at -1, and we go up 3 over 2, up 3 over 2, up 3 over 2, or down 3 left 2, down 3 left 2. Now, because this is not equal, it's just less than, we're going to draw a dashed line. And again, that indicates that the points on the line are not solutions, because if they were to be plugged in, they would make both sides equivalent, and we don't want both sides equal. We want one side to be less than the other. So now again, because it's less than, we want to shade under the line. So look at the y-axis. We want to shade where the y-axis is pointing down for it to be less than. So under the line would be shaded here. And when we're shading, we're not coloring in the whole area. We're drawing perpendicular lines to the line that represents the equation. So now every coordinate in that shaded area is a solution to our equation. And if we plug them into the equation, it would satisfy the equation or the inequality. So in this case, we want to see if the point 4, 5 is part of the solution. So to do that, we're going to plug it in. But first, let me just show you in the graph where that would be. So 4, 5 is this point right here. Now, it's on the dotted line. Since it's on the dotted line, it should not be a solution. It should not satisfy the inequality. So let's prove it. Since this is the x, it gets plugged in for the x. This is the y, it gets plugged in for the y. So we do 5 is less than 3 halves of 4 minus 1. So 5 is less than 4 divided by 2, which is 2, times 3 is 6, minus 1. So 5 should be less than 6 minus 1, which is 5. 5 is not less than 5, so it is not a solution. Now, if that was equal, less than or equal, then it would be a solution. But since it's just less than, it's not a solution. It doesn't satisfy the inequality. All right, let's take a look at another example. Number 2, again, an easier one because it's already in slope-intercept form. So we're going to start at 5, 1, 2, 3, 4, 5, which is way up here. And then we're going to go down 1, right 1, to have a negative slope of 1. Or up 1, left 1. Now in this case, we're going to draw a solid line because it is greater than or equal to. Remember to put arrows on both ends. And now we want to shade above the line or where the y-axis is pointing up. And every point in this shaded area would be part of the solution set, including the points on the line since it is a solid line. Now we should also label the line with the equation. All right, so now we want to justify or solve to see if the point -2, 7 is part of the solution. By doing the work, you are justifying. So again, this would be the x and this would be the y. Let's check to see where that point lies. So if I actually look for the point -2, 7, it's left 2, up 7. It would be this point right here. So since it's on the line, it should satisfy the inequality. So we do 7 is greater than or equal to -2 plus 5, which is 7 is greater than or equal to 2 plus 5. 7 is then greater than or equal to 7. Now, 7 is not greater than 7, but it is equal, so that satisfies the inequality. And now we've justified that it is part of the solution. Okay, let's take a look at another example. Number 3. All right, now it's going to get a little bit more challenging because now we have an inequality in standard form instead of slope-intercept form. So we have to start by subtracting 3x from both sides. That gives us negative y is less than or equal to negative 3x plus 1. Then we divide by negative 1 to get rid of the negative and divide by negative 1 again. Remember, when we're dividing by a negative, that flips the inequality sign. So now instead of it being less than or equal to, it's greater than or equal to. And a negative divided by a negative gives me positive 3x. A positive divided by a negative gives me negative 1. Now it's in slope-intercept form and ready to be graphed. So we go down to negative 1 and up 3 over 1, up 3 over 1, up 3 over 1, or down 3 left 1. Draw a solid line through those points. With arrows on both ends. Label with the original function rule that 3x minus y is less than or equal to 1. And we have to shade. Now when we're shading, we're using the new equation. Since it's greater, we're going to shade where the arrow for the y-axis is going up. So we're shading above the line. And now again, any point in that solution set is a solution to the inequality. So we're going to check some points. So we want to justify and see if negative 2, negative 7 is a solution. So negative 2, negative 7 would be this point right here. So according to the graph, it should be a solution. Let's prove it. So we would do, again, this is the x, this is the y. In the original equation would be 3 times negative 2 minus negative 7 is less than or equal to 1. So that's negative 6 plus 7 is less than or equal to 1. And negative 6 plus 7 is 1, and that is less than or equal to 1. So we've proved that it is. And again, your work is your justification. All right, and then we want to check with the point 110. So 1 and then over 10, 2, 4, 6, 8 is way up here somewhere. So it looks like it should be in the solution set, but let's prove it. If we do 3 times 1 minus 10 is less than or equal to 1, we get 3 minus 10 is less than or equal to 1. We get negative 7 is less than or equal to 1, which is true, so it is a solution. And again, your work is your justification. All right, let's take a look at another example. Okay, so for number 4, again, we have to do some work to get it in slope-intercept form first. We're going to subtract 4x from both sides. So we get negative 10y is greater than negative 4x. And I believe it should be negative 60, so minus 60. Divide by negative 10. We get y is now less than. Negative over a negative gives me positive 2/5 x plus 6. So we start up at positive 6. And we go up 2 and over 5, or down 2 and left 5. So we only get those 3 points, but that's enough. We draw a dashed line since it's not equal. Arrows on both ends, and label with the original function rule. Now in the new function, the transform function, it says less than, so we shade where the y-axis is pointing down. So all of this area is solutions to the inequality. Okay, and now we're going to see if some points are solutions. So we start with the point 5, 8. So 5, 8 would be right 5 and up 8. And that's right here on the dotted line. So if you remember, if it's on the dotted line, it shouldn't be a solution, but let's double check. So we would again put this in for x and this in for y. So 4 times 5 minus 10 times 8 should be greater than negative 60. So 20 minus 80 should be greater than negative 60, but 20 minus 80 is negative 60. So we have proven that it is not a solution. Again, because this inequality wants it to be greater than, not equal to. And then we have the point negative 3, 4, which is left 3 and up 4, which is this point right here, which looks like it's in the solution set. So let's prove it. We do 4 times negative 3 minus 10 times 4 should be greater than 60. So we have negative 60, I keep forgetting that. Negative 12 minus 40 should be greater than negative 60. And that's negative 52 should be greater than negative 60. And it is, so it is a solution. Okay, so you can prove it's a solution by stating that it's in the solution set in the graph or justifying that it works in the equation. Okay, so hopefully you're catching on, you're understanding the rules of how to shade. Because you're now going to do 5 through 8 on your own or with a partner. Please, again, make sure you check in with me so I can be sure that you've got it right before moving on to your exit tickets.